and today I'll be talking to you about SleepCoacher, which is the first step towards a personal sleep coach for every user. And this work was done at Brown University with my advisor, Jeff Huang, and 2 other students, Danaë and Adrienne, who are both here, as well as 3 sleep clinicians and experts on behavior change. First of all, before I start, by a show of hands, how many of you sleep? Okay, and how many of you are satisfied with your sleep? Exactly. Some of us, most of us are not. So this project will hopefully address that. Going further, did you also know that there are 40 million people just in the United States who suffer from long-term sleep disorders, and another 20 million suffer from occasional sleep problems. And that's just in the United States. Currently, there are only 2 possible solutions for improving sleep. There is polysomnography, which is an expensive and obtrusive study which is performed overnight in a sleep clinic. And although it gives you detailed diagnosis and clinician advice, you do have to sleep with a bunch of electrodes on your head, on your scalp, and your eyelids, so it's very uncomfortable and it cannot be performed very frequently. The other solution is sleep tracking apps, which provide you mainly just descriptive statistics, and they usually don't give you any recommendations, let alone clinician advice, but they are very accessible as they can be downloaded for free on smartphones. So just so you're on the same page, this is how sleep tracking apps usually work. When you go to bed, you start the sleep tracking app, and then you put the phone on the bed so that you can track your movement with the accelerometer and the noise level of the environment with the microphone. And then when you wake up in the morning, you just stop tracking, and you can enter a sleep rating of how you feel, and also tags with anything that was relevant from the day before. So for example, if you drank coffee or exercised, that's something that you can tag to keep track of. Anything that might have influenced your sleep. So we wanted to find a solution that combines these approaches and gets the best of both of them. So we set out to create a better solution that is both easily accessible, so it can be downloaded on smartphones, can be used at home so that you don't have to go to a special sleep clinic for it, and it also gives you advice, which is something you just don't get with the current sleep tracking applications. That's how the idea behind SleepCoacher developed. So SleepCoacher is a system based on a sleep tracking application which integrates personalized and data-driven recommendations, and it's based on feedback from professional sleep clinicians. So in a simple summary, that means that it's like a regular sleep tracking app that you use, but then you get a recommendation to do something and change in your behavior. So you try it out for a few days when it tells you to, and then in the end it tells you, yes, this helped you or not. And that way you can improve your sleep little by little through these mini experiments that you run on yourself. And I'm going to explain that in more detail as we go on. First of all, SleepCoacher, since it's integrated with a smartphone app, it uses the sensors that sleep tracking apps use, which is the accelerometer for movement data, and then the microphone for noise level data. And we use heuristics from the sleep literature to classify the sleep versus awake stages. That's from the raw sensor data, you can label data as an activity, so an active moment, when it's above a certain threshold. And then based on that, you can label the person as awake if they have more than one of these activities within a 2-minute period. Or you can label them as asleep if there has been no activity like that for 20 minutes. So SleepCoacher then employs a closed feedback loop. The first step is obviously collecting the data. So we have the sleep tracking app on the user's phone, and it just downloads data it uploads data to the cloud. So SleepCoacher is compatible right now with the most popular Android sleep tracking app, which is called Sleep as Android, and we use the modified version of it for this study. And like in the video earlier, it uses the accelerometer for the movement data and the microphone for the noise data. And in order to start tracking at night, you just press the little moon button at the bottom. And then when you wake up in the morning, you give it the 1 to 5 star rating, and you can add all the tags of anything that was relevant. We used the star rating as 1 star being the most tired and 5 stars being the most refreshed. And then the app automatically uploads the data to the cloud from where our system takes over. So from the raw sensor data, SleepCoacher computes the sleep variables and calculates the correlations between them. So that means that we have the sensor data and we can calculate things like how long it took you to fall asleep and the number of awakenings during the night. And we also have data about what time you went to bed, what time you wake up, so how long you slept. And we also calculate how many times your alarm rang in the morning and how many times you snoozed it. So in this figure, you can see 3 colors of bars, which represent the correlations between each of the independent and dependent variables. So the independent variables are things that the user herself can affect. So like what time you go to bed and what time you set your alarm for. And the dependent variables are things that you can't control yourself. So like how refreshed you feel in the morning and how many times you wake up during the night and how long it takes you to fall asleep. So the ratings is in blue, which is how refreshed you feel. Awakenings is in red. And onset latency is how long it takes you to fall asleep, and that's in green. And on the y-axis, we have all of our independent variables, which are things like the wake time and the bedtime and hours slept and all the tags that the users also manually entered. You can enter a tag for anything that you want. There's some predefined ones like caffeine and exercise, but you can do your own, such as meditate or showering before bed. So that way, the system calculates all these correlations between all these variables, and then it picks the highest correlation as the most likely one to lead to causation. But again, this is just correlations, and we can't know if this is a causal link for now. So for example, if we have this person, this is one sleeper, and their highest correlation is between bedtime and rating, that doesn't mean that it's a causal link. So we need to run an experiment to see if there really is a causal link. Oops, yeah. That's why SleepCoacher guides the user through a self-experiment, which is to check if this high correlation actually leads to a causation. And in self-experiments, that means that the experimenter is also the only subject. So usually they have the ability to decide what to test and how they want to run their experiment. But we say that this is a guided self-experiment because SleepCoacher is the one telling you what exactly to edit, to change in your behavior, and also to recommend how to proceed with the experiment and when to change it. So the setup of the experiment itself is based on the standards for single-case designs, which actually were developed by a panel of experts on quantitative methods and suggest that the best design for single-case experiments are the A-B phase designs, where the A phases are the baselines, where you just collect data, and the B phases are the intervention periods, where you introduce the behavior change. And each of the phases also is recommended to have at least 5 data points, which for us means 5 nights of sleep, because 1 data point is 1 night. And that's why it's really hard to do a live demo, given that I would need you to sleep right now. And so once the SleepCoacher system has picked the highest correlation, we want to be able to give you a recommendation that's related to it, and so that we can test for causality. So that's where the input of the clinicians that we collaborated with was the most important one. So we worked with the sleep clinicians to develop a collection of 114 recommendation templates, with each independent and dependent variable combined together. So for example, if we had the bedtime and rating combination, the recommendation we would give to you would be something like, on average, you go to bed at X p.m. We've noticed that when you go to bed around Y p.m., you feel more refreshed in the morning. So for the next 5 days, try going to bed at Y p.m. to feel more refreshed. So the idea is that once we have this template, we have to fill it out with the statistics for the specific user. And they are calculated so that, for example, the first blank would be their average bedtime. So on average, you go to bed at 11. But when you go to bed at 11:30, your optimal bedtime, that's when you feel better. So for most of these combinations of variables, we had more than one recommendation possible. So we needed the clinicians to rank what's the best recommendation to give for this correlation. And once they ranked them, we used that rank as the probability of which recommendation the user was going to receive. And then SleepCoacher, once the SleepCoacher creates the recommendation for you, it also guides you through the self-experiment so that you can know when exactly to change your behavior according to the schedule of the experiment. And finally, after the end of the experiment, it calculates whether following the recommendation really improved your sleep or not. And if it did, it sends you a text message, or if it did not, it sends you a text message with the conclusion. And then the cycle repeats, and the idea is that you can run these mini self-experiments on yourself many, many times. So if you improve something with your bedtime and your rating now, next you can improve something with how long it takes you to fall asleep. So let's see SleepCoacher in action. So like regular apps, the user switches on the app before she goes to bed and puts the phone next to her in bed. And that way SleepCoacher can use the accelerometer and the microphone to collect the data. And then when the user wakes up in the morning, she stops tracking, like the regular apps, and she rates how rested she feels, with 5 stars being the most refreshed. And then she also tags variables like work or caffeine that were relevant to her sleep. And then the app automatically uploads the data to the servers. And then every day we run a set of algorithms to calculate how long it takes for you to fall asleep and how many times you wake up during the night. And then we send you a daily feedback of how you compare to the other participants in the study or in general in the system. So for example, here it is, last night it took you 20 minutes to fall asleep, which is 2 minutes longer than the rest of the participants in the study. And we had a few of these varieties that changed every day, and participants received a different one basically every day. So we conducted 2 user studies to evaluate SleepCoacher. The lessons from the preliminary study informed the design of the final study. So the goal of the preliminary study was to figure out what do sleep clinicians even look for when they're giving recommendations. So when you go to one of these sleep clinics, what do they look at to give you this professional advice that is so valuable? And we used that finding and to automate the process so that we can make SleepCoacher give you these recommendations automatically. And so the final study also included the longer time frame of 3 weeks. So it took 3 weeks to check for one recommendation if it helps you or not. And in order to check for causation, those 3 weeks were a guided self-experiment, which was based on the single case design standards. And here's a breakup of how exactly that worked. So for example, during the yellow phases are the A phases when you're just tracking your sleep. So through the 8th through the 12th, I'm just using the app. Then on the 13th, you would receive a recommendation. And then between the 13th and the 18th, you follow that recommendation, and the app reminds you every day that you need to follow it. And then between the 19th and 23rd, you don't follow it again. And then the last 5 days, you follow it again. So there's this alternation between following it and not following it. And the idea is that way you test whether it actually helps you or not. And let's see it. Okay, for this part, I also have a visualization. But during the A phase, the user was tracking her sleep. So let's imagine that now is the 13th, Saturday the 13th. So the person receives the personalized recommendation, which says on average you go to bed at 11:52, and we've noticed that when you sleep around 11, you're on average more refreshed. So for the next 6 days, try going to bed at 11 p.m. to feel more refreshed. So during the B phase, we tested, and the user goes to bed at the recommended time at 11 p.m. And then at the end of the 3-week cycle, we check if there was a significant difference in the sleep quality during the last 3 weeks between the blue phases and the yellow phases, so when they follow it and they didn't follow it. And then we send them a conclusion, which is, for example, based on your data for the last 3 weeks, going to bed consistently at 11 has helped you feel 40% more refreshed. So overall, the focus of this study as a whole was on creating the system and building the recommendation pipeline, but the results do show some promise. So here you can see the improvement rate on the y-axis and the adherence rate, so how much people followed our recommendation on the x-axis. And we can see that the more that they adhered to our design, the more this target sleep variable improved. So if they didn't follow our recommendations, their sleep didn't improve. But if they followed it at least 65%, everyone improved. Okay, the improvement rate might not seem large, but just remember that sleep is crucial. We do it every day, so the improvements add up over time. So even a small improvement now will help you later in life. And one lesson that we learned from the individual was how much individual variation there was for some sleep variables. So for example, we have 2 users and they both have a high bedtime and rating correlation. For the first user, it's a really high negative correlation. So that means the later they go to bed, the better they feel in the morning because it's negative. But there's a different user who it's a positive correlation. So the later they go to bed, the better they feel in the morning. I don't know if I flipped it, but one of them feels worse in the morning. The other one feels better when they go to bed at the same time. So it's important to remember that correlation doesn't necessarily mean causation, and that's why we need to test it. And there's so much individual variation that we just can't give general recommendations to everyone. And one more thing we found was when we looked at the ratings across every user. So here each dot is a user. Some variables had more variation than others. So bedtime was highly variable between positive and negative correlations. But our sleep was always positive, so everyone felt better when they slept more. And given that this study was run with undergraduate students, it kind of makes sense because they're all underslept, but it's a good thing to keep in mind for when running these experiments. So in summary, in order to understand how somebody's sleep changes, we need to discover causal effects. So SleepCoacher does this by helping people run experiments on themselves, and these experiments distinguish actual causation from just correlation. So from now on, we want to improve on our work, and we found out that short studies are not good enough. So that's why we're introducing the 10-year sleep study, which we'll be working on from now on. We want to give people the opportunity for a better lifetime of sleep, so we need to run longer experiments. In a 10-year study, people can do many of these mini self-experiments on themselves, and they can stop whenever. And we'll be running this actually as a remote study on our own apps for Android and iOS that we're developing right now. And it will start right on time for New Year's resolutions on January 1st. So if you want to be involved or be a part of it in the future, you can sign up at sleep.cs.brown.edu. And we also have details and open source code of our project available at the same website, sleep.cs.edu. And you can feel free to contact me. And thank you. I'm happy to take questions.
Okay, we have time for a couple of questions. You mentioned it firstly for doing a longitudinal study.
Hi, Mira Doncheva, Adobe Research. Thank you. Really nice talk, really nice work. I guess I'm curious, there's sleep time and sleep duration, but there's also other factors like sleep quality. And so can you talk a little bit more about sleep quality and how the recommendations address some of the qualitative sleep issues like tossing and turning, potentially snoring, all these kind of more potentially even medical concerns?
Thank you for the question. That's a very important question, especially since a lot of the apps that are currently in the market promise you give you a sleep quality rating, like 70% sleep efficiency or sleep quality. And after working with the sleep clinicians for so long, we realized that there are way too many factors that the smartphone just can't account for. We're basing our studies just on the microphone and the accelerometer data. So we're focusing more on transient problems that regular people have, not so much on deep issues such as sleep apnea, which definitely need a polysomnography for. But if it's somebody who's just dissatisfied with their sleep and want to improve it little by little, this is for them. But also a lot of these apps promise that they give you details like sleep stages and so on. And the sleep clinicians, it's widely believed that you can't infer sleep stages or sleep quality just based on movement because it's based on brain waves and you can't distinguish out beyond that. So, yeah, thank you.
Hello, Pablo Paredes from Stanford. So I have a couple of questions about adherence and engagement, because the problem with apps for behavior change is really the long-term use of them. So how many people did actually abandon the study? And how did you motivate them to be in the study? Because I'm more concerned of the 100% population, how many actually do get to use the thing and how many actually do get to comply and not relapse to prior sleep. That's actually what we really care for. And the second question is, I see that your adherence shows that if you actually comply with less than 40%, you actually get worse results. Does that mean that the app is actually inducing them to be more maybe anxious and it actually affects them? So if they don't use it well, your app actually becomes an exacerbation problem for the sleep study?
That sounds, okay, second question. That sounds horrible. I hope not. But also we based adherence rate on just during the phase when they have to follow the recommendation. So if they never follow the recommendation, their adherence rate will be 0. And we can't be sure why their sleep is decreasing. But if we can see from our data that they're not following the recommendation, then it wasn't that the recommendation worsened their sleep. But it is possible that they're aggravated. And this is college students, so we all know about social comparison and how they get affected from looking at other things. So in that point of view, we can't be sure for that. And for your first question, which I forgot, the population, yeah. We had 17 undergraduates in the second study. We paid them $50 for the 6 weeks, and we told them that we had a screening process before we signed up for the study. We wanted to make sure that they actually want to follow the recommendation, and we warned them what they might be like. And only people who promised that they would come through the recommendations and wanted to improve their sleep were signed up for the study. So $50 is not a lot of money for 6 weeks, and we were hoping that would have been more internally motivated. We used the same $50 for, oh sorry, never mind, we're done. Oh, we used the same $50 for the initial study we did, which was only 4 weeks, and then people didn't follow our recommendations. So we really needed to find self-motivated people for the second study. That answers it.
Thank you very much. Thank you.